Here we are, composing trig functions with inverse trig functions. And what is meant by that is, if you recall f of x of g of x, we are essentially doing that with inverse trig functions and trig functions. We see an example that we have solved previously in the lesson before this one. So we have arc cosine within the sine function. And how we do this. So we need to remember that arc cosine is going to give us an angle measure, and then sine of that angle measure, we're going to get a ratio as a result. So from the previous lesson, we saw that with trig functions, we inputted into a trig function an angle, and as an output we get a ratio of side lengths. Well, with inverse trig functions, our input, as you can see in this example, is a ratio of side lengths. And our output is an angle measure. So we are going to get an angle measure from this arc cosine. And with that angle measure, we'll be able to say what it equals. So we don't know exactly where cosine, for what angle cosine is negative 2 over 10. We do know what cosine is at certain angle measures, pi over 6, pi over 3, 2 pi over 3, pi, and so on. But for negative 2 over 10, we don't really know. So what we can do here is we can create a reference triangle. So thinking of a reference triangle, negative 2 over 10, so cosine is adjacent over hypotenuse, so hypotenuse can never be negative, so we're going left 2 and up 10. Not up 10, but our hypotenuse is 10. Okay, there's our angle. So the unknown side, using the Pythagorean theorem, let's see, it would be 10 squared equals a squared plus negative 2 squared. So you get 100 equaling a squared plus 4. So you would get a to be the square root of 96. So now, if this ratio was something that we know, for example, the arc cosine of 1/2 is going to be pi over 3. The arc cosine of 1 is going to be 0. But the arc cosine of negative 2 over 10, we don't know that exact angle measure. So when we say that this is going to give us an angle measure, we don't know what it is, and that might present an issue for you. But it doesn't matter, because sine of an angle measure is opposite over hypotenuse, and from our reference triangle, we can see what that is. So sine of our angle measure, it's okay that we don't know what it is, because sine of this angle measure is square root of 96 over 10. So we've seen an example of this before in the previous lesson. I'll put a link here so you can go back and look at another example of this. But what if we don't know the ratio? So what if we have, per se, a tangent of arc sine of x? So we don't know what the ratio is. That's okay, we can still do this. So understanding what arc sine is going to give us an angle measure, and with that angle measure, we can take the tangent of it. So we're going to use a reference triangle again. So being positive x, so here's our angle. Sine, so we can say sine of theta equals x. That's what arc sine, inverse sine is. Arc sine, so sine of theta will equal x. So x, that's actually x over 1. So sine of theta equals x over 1. So sine's opposite over hypotenuse. So the opposite must be x in that case, and our hypotenuse must be 1. Sine of theta is x over 1. So then our unknown side, using the Pythagorean theorem, we have 1 squared equals a squared plus x squared. We're going to move our x squared over to be 1 minus x squared equals a squared. So then this length a is going to equal the square root of 1 minus x squared. So this is a side length. So now, knowing this side length, I can find the tangent of our angle. So we don't know the actual value of the angle, but that's okay, because tangent is opposite over adjacent. Opposite to our angle is x. Adjacent to our angle is the square root of 1 minus x squared. So what can be said now is that tangent of arc sine of x will always equal that x divided by this expression. So say I put 2 into this. Let's just imagine that I place 2 into this value. Actually, not 2, but let's say -1/2 or -1/3. That it would equal -1/3 divided by this expression. Okay, so this expression is what this composed function will always equal. Let's try another. Let's say I wanted to know what cosine of arc sine of 2x and what that equals. So again, reference triangle. So this is going to equal cosine of some angle. So we're going to find the adjacent and the hypotenuse. So we have our angle here. Sine is opposite over hypotenuse. So looking at it as a fraction, our opposite would be 2x. Our hypotenuse would be 1. Pythagorean theorem would have us write 1 squared equals a squared plus 2x squared. So that would equal 1 equals a squared plus 4x squared, which solving for a, square root of 1 minus 4x squared. That's our unknown length, which allows us to find cosine of the angle. So when we have cosine of arc sine of 2x, with x in our domain, cosine of this expression will always be adjacent over hypotenuse. Always. Something to remember with arc sine, arc cosine, the domain here for those two is from -1 to +1. So, which is why I said earlier, when x was 2 here, I had to change it to -1/2 or to -1/3. It's because 2 is not within the domain of arc sine. That's why I couldn't really use it there, because you'd try to solve this, and you would end up having a negative within the square root, and that just wouldn't work for us. Okay? So one more to end this lesson. Okay, so let's talk about cosecant of arc cosine of x over x square root of x squared plus 9. So this looks a little nasty, but let's just take it using our reference triangle and see what we can do in this problem. So creating the reference triangle. Okay, cosine adjacent over hypotenuse. So we're saying cosine of theta equals x over square root of x squared plus 9. So with the Pythagorean theorem, let's see what we would have. So square root of x squared plus 9 squared equals x squared plus a squared. So solving this, square root exponent cancel. Okay. And then x squareds on both sides, so they would cancel, to giving us 9 equals a squared. And then we would see from that that a must be equal to 3. So our unknown length is 3. We needed this unknown length because arc cosine is going to give us some angle measure. And with that angle measure, we're going to write the cosecant ratio. Cosecant is the reciprocal of sine. So cosecant is hypotenuse divided by the opposite. So our expression, cosecant of arc cosine of this value equals, and will always equal, with x in our domain, this expression. Ending the video, I just would like to talk about going to something much simpler. What if I had the cosine of arc cosine of x? So this goes back to understanding inverse functions. So I placed an inverse function, I placed a function into its inverse. I place arc cosine into its inverse. So if you remember the properties of inverse functions that we will always get when we do f of g of x, we will always get x as a result. So when we place arc cosine into cosine, we will always get x. As we would if I place arc sine into sine, we would always get x. And if I place arc tangent into tangent, we would always get x. And x here, our domain will be for, so I want to say this. And for these three, x is within -1 and +1. Now, if I were to switch this, if I were to say arc cosine of cosine of x, arc sine of sine of x, if the regular trig functions are the inner part, they are not always true. So they will not always equal x. And it's because of the restricted domain, as we talked about in the previous lesson. This is always true. In our text, we can see the other situations where it's not always true. But remember here, arc sine, cosine, arc tangent give us an angle measure. And with that angle measure, we get a ratio. When we don't know the angle measure, we can use a reference triangle to find the ratio. So I wish you the best of luck with these problems. I would not be surprised if you need to go back and watch this again. But we're going to be practicing this some more with other compositions. But ultimately, it comes down to creating a reference triangle, and with that reference triangle, finding the third side, and with that third side, writing the ratio. So I'll see you in the next video. And again, best of luck practicing this.